Welcome to Maths with EJD. In the past few videos, I've been talking about basic calculus. In fact, the last set I talked about was about techniques of differentiation on different kinds of functions and all that. So I also got to do some proofs for some of the popular rules attached to differentiation. So, in this set of videos, I'll be talking about the fourth module of the course, which is applications of differentiation, applications of differentiation. And when we talk about applications of differentiation, we are talking about these four things in particular. We are talking about kinematics, we are talking about linear approximations, rates of change, stationary and turning points. And I'm going to make a video for each of these applications. So it will be 4 videos in all for applications of differentiation. Okay. And then the first one is kinematics. Straight to the point, you need to understand what kinematics is about. So kinematics is simply the branch of mechanics that deals with the motion of bodies, objects, or particles without concern for the forces that cause the motion. So you see, it's about motion, right? Motion doesn't just happen without a force causing it. But kinematics doesn't care about the force causing it. If you want to, if you're interested in the force causing motion, then you'll be talking about dynamics. So it means that mechanics in general is all about motion, how the motion is happening and the forces causing the motion and all that. But then mechanics is divided into kinematics, which talks about motion without worrying about the forces causing it. And then dynamics is concerned about the forces causing motion. So kinematics is otherwise known as the geometry of motion. So it's basically about the pattern of motion, how the motion goes, in what way is it like a parabolic motion where the thing goes and it reaches a peak and comes down or something like that. It goes on a straight line, different things like that. So all about the geometry of motion. And it is concerned with quantities like displacement, velocity, and acceleration. And of course, differentiation is useful in kinematics owing to the fact that the derivative of displacement is velocity and the derivative of velocity is acceleration because by definition, right, velocity is the rate of change of displacement. Displacement is distance between 2 points in a specified direction, right? So velocity is the rate at which that movement happens from one point to another. And acceleration, on the other hand, is the rate of change of velocity. And of course, we can even take it higher and talk about the rate of change of acceleration, which is JERK. JERK. That's a jerk, like that. Okay. So let's take examples that will drive this right home. So that was slide 5. So we go to slide 6. So you have this. If the displacement of an object is given by S equals T cubed plus T squared plus T minus 1. So now this expression is describing how the body is moving between from one point to another in a specified direction, right? So we have to find the velocity, which we know is the rate of change of displacement. And of course, we are looking for the acceleration, which is the rate of change of velocity. So it means to get the velocity, you differentiate that expression. To get acceleration, you differentiate the expression you would get for velocity. And of course, we need to find that at time t equals 4 seconds. That means that you put 4 seconds into each of the expressions you get, and you get what you need to get. So since we have s equals t cubed plus t squared plus t minus 1 for the displacement, then of course the velocity would be this v of t, which is ds dt. That's the rate of the change of displacement with respect to time. The rate of change of displacement, right? So yeah, so and then that means you differentiate t cubed, you get 3t squared. Differentiate t squared, you get 2t. Differentiate minus 1. I mean, differentiate t, rather, you get 1. Differentiate minus 1, that's 0 because it's a constant. So now you have your velocity, the expression for your velocity, you have it right here. So at time t equals 4 seconds, all you just need to do is to put 4 wherever you find t. So 3t squared becomes 3 4 squared. 2t becomes 2 4. 2 times 4, that is, and then this is plus 1. 4 squared is 16 times 3, that's 48. 2 times 4 is 8, and then you have 1. That's 48 plus 8, 56 plus 1, 57. So at time t equals 4 seconds for that body moving with that displacement, the velocity is 57 meter per second. 57 meter per second. And of course, if you need to find the acceleration, it is a of t, which is dv dt. Acceleration is the rate of change of velocity. That is the change of velocity with respect to time. And that means you just differentiate the displacement, I mean the velocity you earlier got, differentiate 3t squared, you get 6t, differentiate 2t, you get 2, differentiate 1, it's 0 because it's a constant. So now you have the expression for your expression for acceleration, right? And then at time t equals 4 seconds, just put 4 wherever you find t. So you have 6 times 4 plus 2. 6 times 4 is 24 plus 2, that's 26 meter per squared second. So for the object doing that motion, the acceleration at time t equals 4 seconds is 26 meter per second. And there you go. All right. So let's do something a bit more, the kind of questions you find in physics. Okay. Example 2, a ball is thrown in the air and follows the displacement function. So you have this displacement function now, minus 4.90 squared plus 4.90 plus 9.8. That's like a body falling under gravity, right? Like a projectile, right? So where t is time in seconds and x is displacement above the ground. Now the first question, what is the initial height above the ground from which the ball is thrown? B, at what time does the ball reach its maximum height? You know, when you throw something in the air like that, so it reaches the maximum height and then it ascends first of all, maybe, or if it is from a level, so it gets to a point and then it begins to descend. Now, what is the maximum height above the ground? Then the last question is determine when the ball hits the ground. And then what is the acceleration of the ball at t equals 1 second, t equals 1.5 seconds, and t equals 2 seconds? What do you notice? Okay, maybe from our answers, we'll get to see what we notice. All right, so let's see. Okay, I think this is good from a reference, which is the reference is the question 3. I mean, reference 3 rather. So now we have the displacement function, which is this x of t equals minus 4.90 squared plus 4.90 plus 9.8. So we want to find the initial height of the ball. So the initial height of the ball is obtained when t equals 0. That is the height from which it is projected. So that is where at the height where the ball was projected, time is equal to 0, right? So in that case, just substitute 0 there, t equals 0 in the expression. So you have x of 0 equals minus 4.90 squared plus 4.90 plus 9.8. So at the end of the day, this anywhere you have 0 goes away, and then you have only this 9.8 left. So it means that the ball was projected from a height of 9.8. And that because that happened at time t equals 0, you obtain that by substituting 0 into the displacement function you have. The second question wants to find out the time at which the ball reaches its maximum height. Okay, so you projected the ball from a height. It's more like, this is a height of 9.8 meters above the ground. Then the ball is like projected like that. So it gets to a height and then it begins to descend. So this is like the maximum height. I want to know that the time it takes to get to the maximum height. That's the second question. So the time it takes to get to maximum height is obtained this way. The maximum height above the ground is obtained when x prime of t is 0. You know, maximum height is where occurs at a point where the body stops momentarily. It stops it stops accelerating momentarily. And when it is not accelerating, that means that the velocity is equal to 0. I know if x of t is displacement, then x prime of t is velocity, and then x prime of t is acceleration, you know. So for the body to reach maximum at the maximum height, right, the velocity of the body is 0, such that when you differentiate, if you differentiate this, right, you get minus 9.8 t plus 4.9. When you differentiate that, that's the velocity of t, which is the same as x prime of t. So basically, we know that this body, when you differentiate this now, you have minus 9.8 t plus 4.9. 9.8 goes to 0. This is 9.8, so it goes to 0. So it means your x prime of t is simply minus 9.8 t plus 4.9. But at maximum height, x prime of t is 0. So it means this whole expression will be 0 at that maximum height, you know. So then we are solving for t because that's what we are asked to do. So that implies that, since you're looking for t, so you can transfer minus 9.8 t to the other side. So you have 9.8 t equals 4.9. That means that t itself is 4.9. divided by 9.8. That means it is 0.5 seconds. So the object reaches the ball reaches its maximum height at t equals 0.5 seconds. So then the other part is to find, we want to find at what time the ball reaches its maximum height. Then what is the maximum height above the ground? So since we know the time it takes to reach the maximum height, so then we can also find the maximum height. So to get height, height is displacement, right? So for height, it is still displacement. So you go back to that original expression for displacement. That is how you get height, okay? So you just put the time you got is 0.5. So put it back in that expression. So you have minus 4.9 into 0.5 squared plus 4.9 into 0.5 plus 9.8. And when you put all of that together, your expression is 11.025 meters. So that means that the ball takes 0.5 seconds to reach the maximum height. And that maximum height you obtain by putting 0.5 into the original displacement expression. And that translates to 11.025 meters. So that way we have answered A and B. So we have B, C, and D to go. We want to determine the ball when the ball hits the ground. Okay. When does the ball hit the ground? That's the next thing. So, and the question is, the ball hits the ground when x of t equals 0. That is the height. When the ball hits the ground, height is just 0, right? The ground from the ground is 0. So at that point, x of t is 0. So to do that, just express your displacement as 0. So you have minus 4.90 squared plus 4.90 plus 9.8 equals 0. I mean, you can say minus 4.9 is common. So you can divide through by minus 4.9, minus 4.9, minus 4.9, minus 4.9. So you see, minus 4.9 cancels minus 4.9. So you have t squared, then plus 4.9 divided by minus 4.9, that's minus t. Then plus 9.8 divided by minus 4.9, that's minus 2, and that is equal to 0. So in this case now, this is a quadratic equation which you can solve using whatever method you know. Here I've chosen to use the formula method, which people call almighty formula. And I keep wondering what is almighty about this simple formula, right? So you have t equals minus, that expression minus b plus or minus square root of b squared minus 4ac divided by 2a. A is the coefficient of t squared, which is 1. B is the coefficient of t, which is minus 1. And c is minus 2, which is the constant. So that is exactly what we are doing here. So we have t equals minus, this is minus b. So b is minus 1. So minus 1 plus or minus square root of b squared, because minus 1 is b, then minus 4 times a times c. C is minus 2 divided by 2a. That is 2 times 1. So minus 1 is 1, plus or minus. Then minus 1 squared is 1. Minus 4 times 1, minus 4 times minus 4 times minus 2 is plus 8. So there you have it. And 2 times 1 down there translates to 2, right? Because so you have 1 plus or minus. Square root of 1 plus 8 is 9. And square root of 9 is 3. 1 plus 8 is 9, right? Square root of 9 is 3. So you have t to be 1 plus 3, 1 plus or minus 3 divided by 2. So if you take the plus first, 1 plus 3 is 4 divided by 2. That is 2. Then 1 minus 3 is minus 2 divided by 2. That's minus 1. Of course, we want to look at when the ball hits the ground, right? Time cannot be negative. So because of that, minus 1 is rejected. So the time has to be t equals 2 seconds. So it means the ball hits the ground after 2 seconds. So the ball hits the ground like 1.5 seconds after it reaches the maximum height. It takes 0.5 seconds to get to its maximum height from the 9.8 meters from which it was launched. It takes 0.5 seconds to get to that 11.025 meters of maximum height we got. And then it now takes 1.5 seconds to come back to the ground. Because on the ground, the displacement is x of t equals 0. Okay. So the last thing is, we want to know the velocity. What's the last question? Let's quickly check that up again. The last thing is determine when the ball, what is the acceleration of the ball at t equals 1.5 and 2 seconds? Okay, acceleration. So in that case, we differentiate the velocity again. So the velocity of the ball is given as v of t equals x prime of t, and that is minus 9.8 t plus 4.9, which we saw before. And then the acceleration will simply be differentiate this again, and you get minus 9.8 meter per squared second. So you see that the time has no power on this one. So we're at t equals 1 second, at t equals 1.5, at t equals 2.2 seconds, it doesn't make any difference. We notice that the acceleration is minus 9.8 meter per squared second because the ball is falling under gravity. So you see the acceleration is the same because the ball is falling under gravity. So all the time has no effect on it. So, and that is all as far as application of differentiation to kinematics is concerned. So let's go to, let me just show you questions related to this, which you can try your hands on. Let's see. Okay, exercise for kinematics. Okay, here you have it. So you can try your hands on this, see how well you understand the things I've done so far. So you can try this out. And of course, for the references, like I took one of the questions from this reference 3. That is why I put number 3 right there. So you can check it for some kind of applications too, like that. So if you have not subscribed, once again, make sure you do that and then click the bell button so you can always get notifications. So watch out for the next video on application of differentiation to linear approximations. See you in the next one.